Hey guys, this is a help and walkthrough video on the scientific notation Desmos that we started in class. Maybe you didn't finish it, so you're watching this video. If you need some help on understanding scientific notation, what it is, why we use it, then go check out the actual scientific notation help video. It is on YouTube. It's also in the yellow help folder in Schoology. This video is really just walking through this particular assignment where we practice writing in standard form and scientific notation and converting from one to the other. So this is slide 2. Okay, so we have all these numbers in standard form, very large, very small numbers, and we want to write it in scientific notation. How do we do that? In our notes, the very first step is that we want to move the decimal place to create a number between 1 and 10. Okay, and the pro of scientific notation is that it gets rid of the string of zeros, the tail of zeros. Okay, so if we have this first number, 56,700, we're really trying to get rid of these zeros to make it easier to read and write. Where can I put that decimal? If I put that decimal right here, we still have 567. Still too large. We need a number between 1 and 10. If I put the decimal right here, we have 56.7, still too large. So you're going to see that this is the correct placement for our decimal because now we have 5.67. And if you do look at those zeros, we know zeros after the decimal place have no value. So this is a number between 1 and 10. Okay, so to write in scientific notation, we're going to start with that base, 5.67 with my new decimal place. The old decimal, however, was right here. Our original placement for the decimal is after the whole number. So now to figure out our exponent, we need to see how far away did I move that decimal. Okay, so we moved it how many jumps? Over the 6, over the 7, 1, 2, 3, and 4. Okay, so we moved our decimal place 4 place values. So we're going to do times 10 to the 4th, positive 4. And it's a positive exponent because my number is very large. Large as in greater than 1. Okay, so positive exponent. Be very careful when you're completing this Desmos activity. It's very particular with how you type in your answer. We are not going to use the letter X anymore for multiplication. We really use the dot, the point. You can use that by clicking Shift number 8. The star in your keyboard will give you that multiplication dot. Or you can click on, let me do it right here, this keyboard button and actually click the little star for that point as well. So don't use the letter X. Okay, and then the exponent, so times 10 to this 4th power, you're going to click on this button, and then you'll see the little cursor will move up so that you can type a little exponent 4. Or you can type Shift number 6 on your keyboard. This sign, caret, will move your cursor up to that exponent. Okay, so whichever way you like to do it. Okay, number 2, so we're going down 1. This is a very large number. I know it's going to have a positive exponent. Okay, the point again of scientific notation is so that we can cut out that string of zeros. So we're really looking right here at the non-zero digits. See if this makes it easier for you to see. Where can we put that decimal point so it becomes a number between 1 and 10? 723, 72, 7.23. So that's where I want to put my decimal place. My base is 7.23. I'm going to go ahead and click Shift 8, or you can use the keyboard, Shift 8 to get the multiplication, times 10, and then Shift 6, this button. Shift 6, and you can see it goes up to the exponent. How far did I move this decimal? Here's the original placement. How many jumps did I take? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to be a positive 8 because it's a very large number greater than 1. Change colors here. All right, so these two are very small numbers smaller than 1. So we're going to have a negative exponent. Let's look at all of our non-zero digits. Where can I put a decimal so that this becomes a number between 1 and 10? Right here. Okay, 7.67. Shift 8. Your 10, Shift 6 to make the exponent. How far did I move my decimal place? It is small. We're moving it to the left now. You can also see it's going to be a negative number. Let's count now. 1, 2, 3, 4, 5. -5. Okay. Let's look at all the non-zero digits. We just have 4 this time. Where can I move the decimal place? So it's a number between 1 and 10. It's actually going to go behind the 4 right here. Okay, so 4 times 10 to the negative, because it's decimal, 1, 2, 3, 4, -4th. Okay, you can always pause this video. I'm going to keep going, or rewind, rewatch it if you need some more help. In October 2012, Hurricane Sandy devastated several Atlantic seaboard states in the U.S. The total cost of the storm is hard to estimate, but it is probably about this much. So we want to rewrite this into into standard form. So it's already in scientific notation. What is this? What kind of number is this really in standard form with all the zeros, with the string of zeros? Let's see. So my first recommendation is to look at this exponent and see what it tells you. It's a positive exponent, so I know it's going to be a very large number, large as in greater than 1. Okay, so it's going to be a very large number. This also means I'm going to move my decimal place to the right. Okay, because as I move it to the right, the larger my number gets. 10 jumps. Okay, so this exponent will also tell you how many place values to move. So you can move your decimal place 10 place values. So if I started to write here, I'm moving my decimal to the right 10 jumps. Okay, so I got to jump over this 5. That's going to take 1, but I got to keep going. 10 jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here's going to be my decimal place. So what are we going to fill in these gaps? We're going to fill in zeros. 2, 3, 4, 5, 6, 7, 8, 9. You'll notice I have 9 zeros, but I had 10 jumps. So why is that? Well, I had to take a jump to get over my 5. Okay, so this counts as moving 1 place value. So even though we started with 10, it took 1 hop to get over the 5. So that means I'm going to have 9 zeros. So 6, jump over the 5, and then 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I can't click my submit button. How do I move my, I don't know how to move my camera. Okay, so $65 billion in what? Let me see. Devastated several Atlantic states. It cost that much in devastation. So that's quite a lot of money there. Okay. All right, write this number in standard form to determine how many cells are in the human body. So we know there's a lot of cells. This is going to be a very large number because it's a positive 8. This means I have 8 jumps. Okay, 8 jumps. I know that I have to take 1 jump to get over this 4. Okay, so if you can reason that way, I have 8 jumps. I got to use 1 to get over the 4, so I'm going to have 7 jumps left over. That means 7 zeros. Okay, so jump over the 4, that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, that was the place value. Or you can think 1 jump to get over the 4, and then I have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to write this over here just so that you can see the jumps as well. If you can always use scratch paper. So if you want to show your jumps, we have 8, 1, 2, 3, 4, 5, 6, 7, 8. Here's my new decimal place. We can fill in the gaps with zeros, and you can see that we're going to end up with 7 zeros. Okay, if you want to be sure. That's how you show your work. Let's practice a few more. Okay, so 4 total jumps. These are all positive numbers. Actually, let's begin with they're all positive numbers, so they're going to be all large numbers. We have 4 total jumps. Takes a jump to get over the 7, so now we only have 3. Takes a jump to get over the 6, so now we only have 2 extra jumps that we're going to have to fill in with zeros. So 2, 6, 7, 4 zeros. Next one right here, we have 9 total jumps to the right, but I got to take 1 to get over this 1. So if I had 9 jumps, I had to use 1 to get over the 1. So now I have 8 more jumps to the right, that means 8 zeros. 9, 1, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. I have 5 jumps. I got to use 1 to get over the 0. Now I have 4. Got to use another 1 to get over the 3. So now I'm only left with 3. So 3 zeros. 803, 3 zeros. 7. Okay, here's the decimal place for 7. I get 6 jumps. I don't have to jump over any number. There's nothing to my right. So I'm going to use all my jumps for zeros. So I'm going to have 6 zeros. 7 and 6 zeros. 1, 2, 3, 4, 5, 6, 7. Again, though, if you don't want to reason that way, then use your scratch paper and actually show the decimal moving, okay? If this is not a good method for you and it's really hard for you to do something like this in your head, actually show your work. There's nothing wrong with showing your work, and especially if it ensures that you get the answer right. Okay, like for example, this one over here, this 8.03, I'll show my work here. It's a positive exponent, it's a large number. I'm moving my decimal this way. Okay, so 1, 2, 3, 4, 5. I'm going to go and fill in my jumps with zeros, and you can see it's going to be 803,000. Okay, right here. So use whatever strategy makes sense for you. Show your work, physically make the jumps, or if you're good at reasoning, you can think, I got to get over the 0, I got to get over the 3, so only have 3 jumps left. Whatever works for you. All right, let's try examples with decimals. So the mass of a dust particle, so a little piece of dust that's sitting on your desk. It's really, really, really small dust particles. And I know it's also small because this is a negative exponent. So it's still going to tell me how much to move the decimal place, only this time I'm moving to the left, because when I move my decimal place to the left, my number is getting smaller and smaller and smaller. It's becoming a smaller and smaller decimal. Okay, so I'm going to show the work for this one, 7.53. I'm moving my decimal place 10 units to the left. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my new decimal place. Carefully fill in those spots with zeros. And you'll see that we used 9 zeros. Okay, so 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 5, 3. The thing for this one is we know it's a really small number. Okay, so a small number I'm referencing is a number that is less than 1. So we're not going to have a whole. So this is one way to write the decimal, but let's fill in that whole number spot with a 0. So if you include that whole number, this exponent tells us the number of zeros. But again, there's many ways to think about this. You got to use what works best for you. Well, which way makes sense for you? Okay. All right. These are all negative exponents. We're looking at negative numbers. This 5 means we have 5 jumps to the left. We take up 1 jump to get over the 4. That means we're going to have decimal. We're going to have 4 zeros. 1, 2, 3, 4. We can also fill in the front with our whole number 0. Our second one, negative 8. Get over the 2. That means we're going to have 7 zeros. So decimal, 1, 2, 3, 4, 5, 6, 7, 214. Fill in the front. Go ahead and put that whole, where your whole number it typically goes, we have 0 because we're looking at small numbers that are less than 1. 4. Okay, here's our decimal with a whole number. Got to get over that 8, and then we have 3 jumps left. Decimal, 1, 2, 3, 8. We can put our 0 up front as well. 3 jumps. Jump over the 7. So that means we have 2 left. Decimal, 2, 701. And then we can put our whole number 0 up front. So if that system works for you, do that. For negative exponents, you're going to find that we are always using 1 jump to get over that ones place, because no matter what, when we write in scientific notation, we're going to have a number in the ones place, because we're writing a number between 1 and 10. So you can think of your jumps. You can also think, but you're going to have to be careful if you think this way, that for negative exponents, it will tell you the number of zeros, including that 0 up front in our decimal. So if we had -5, you can see in my number right here, I do have 5 zeros, 1, 2, 3, 4, 5, but it also includes that 0 in your ones place. Okay, so 2.14 times 10 to the -8, I do have 8 zeros. 1, 2, 3, 4, 5, 6, 7. 8, it includes the 0 in the ones place. But that only works for negative exponents. So if you don't want to think that way because the exception is negative exponents, then just do your jumps and do your reasoning. Okay, last slide. Just rank how it was, how this assignment was. Do you understand the math today? How did you feel about it? Let me know if there's anything you want to tell me. I hope this video helps. See you guys.